All right, guys, so today we're going to be moving on to 10.2b, which is area of a rhombus and kite. And our mission is I can find the area of a rhombus or kite. Pretty straightforward today. Again, we got to do a little bit of understanding about where the formulas even come from, because again, if we just try to remember formulas, it's going to be difficult. And so far, we've been utilizing as our base area equals base times height. And again, we kind of developed that into a formula we could use for triangles, which was area equals half the base times the height, because a triangle is half of a square. And so one of the first things we got to do is kind of look at a rhombus and a kite themselves and kind of think about what characteristics do both of them have. So I'm gonna draw out just a couple of these here, the best I possibly can. All right, so not too bad. Rhombus, again, has four congruent sides. It does not have right angles. That would be a square. So it has four congruent sides. And also with a kite, we have two sets of congruent sides, right? So there's really no similarities there as far as that goes. They're both quadrilaterals. They're both four-sided figures. But there's really no major significant characteristics there. However, when you start talking about the diagonals of a rhombus and of a kite, there's some interesting things that happen here. And again, forgive me, but I'm doing my best to try to draw these out. And one of the things that happens is that the diagonals, especially with a rhombus, bisect each other, okay? So when we're talking about the diagonals here of this rhombus, then we understand that this here is going to be the same exact length as this one. And likewise, this one is going to be the same length as that one, okay? So it actually bisects those into two equal parts. And then the other thing that happens here, and actually this happens over here with the kite on this particular portion. Remember, the long diagonal bisects the short diagonal. But the other thing that happens here with these figures is that it creates 90-degree angles. So the diagonals are actually perpendicular, okay? So it's pretty important with both of those figures. But again, if we just look at these figures, we can kind of get a glimpse of the fact that there are some triangles here. And as a matter of fact, they're two sets of isosceles triangles. Okay, so one of the things we probably could do to help us to try to figure out the formula for this is just, again, go back to what we know. Go back to the triangles. And so we can deconstruct this just a little bit to try to figure out exactly what's really happening. So what I'm going to do is I'm going to go ahead and take this rhombus, for example, and I'm going to go ahead and deconstruct it just a little bit. And so if I were to deconstruct this rhombus, again, you would kind of get the idea here that this is really kind of like a parallelogram, okay? And the other thing that we would also understand and realize is I want you to understand and realize that these actually have the same exact base. Okay, so these two triangles, they actually have the same base here. If I were to cut them along this line right here, they actually have exactly the same base. But here's the other thing I want you to think about. Let's call this one diagonal 2. We'll call it D2 for short, and let's call this one diagonal 1. Okay, so when I actually think about this along the diagonals, okay, this diagonal 2 is the base of one of my triangles here. So D2 is this diagonal right here. That's what this actually represents right here. Okay, so now though there's a problem. We have D2 and we have D1 here, but it's I don't know that this is really helping us here. We need to think about the height here. Okay, so this height, I want you to understand, is actually not D1 because D1, again, this only goes halfway down because these are congruent to one another. So H is actually 1/2 of D1. Okay, so again, if we're using our formula of area equals base times height, then my area equals my base, which is D2, times my height, which is D1. But remember, my height is actually half of D1. So, ladies and gentlemen, an easy way to be able to do this formula for a rhombus is the area equals 1/2 of one diagonal times the other diagonal. Okay. Then you thinking to yourself, well, wait a minute, that don't make a whole lot of sense. What about for a kite? Well, I want you to notice as well that they still share this same base right here. Okay, I'm trying to draw kind of lightly so you can still see everything else, but they still share that same base right there. So let's think about what really happens when we take a kite. When we take a kite and put those together, believe it or not, we would actually get a long rectangle. Okay. Well, what I want you to think about is, again, let's think about this. Let's call this one D2. We'll call this one D1. Okay. So D1 again, D2 actually is this long diagonal. Okay. So if we stacked this way, we would understand that that is actually D1 right there. Okay. But the height, again, this horizontal height, this perpendicular height that we have here is not just the whole thing. It's not the whole part of D1. It's just this particular part of D1. So again, it would be half of D1 equals our height. So we get exactly the same formula for a kite as well, that a kite is 1/2 of D1. I don't know why I put I times D2. Okay. D1 times D2. So same formula for both of these, and you can kind of see why we grouped them together. So let's go ahead and work through some live examples. I think that's going to be the best way to do this. We'll start with the rhombus first. Okay, so we're talking about rhombuses first, and we'll call this number 1. And so let's say we have this here, kind of looks like a parallelogram, but we're told that it's a rhombus. And we have these particular two little diagonals here. And we're told that this one is 13.5 feet. And we're told that this one is 15 feet. Okay, so what do you remember about a rhombus? Keep in mind that in a rhombus, that these are congruent and those are congruent. Okay, so if it's telling me that this one right here is 13.5, guess what? That means that this one right here is also 13.5. And if it's telling me that this is 15 feet, then that means that this one also has to be 15 feet. So let's think about how we get these diagonals. So let's call this one diagonal 1. We'll call this one diagonal 2. Well, in order to get the entire diagonal, I have to actually add those together. Okay. So again, area equals 1/2 of D1 times D2. So area equals 1/2. That's D1 would be 15 plus 15, which will be 30. And D2 is going to be 13.5 plus 13.5, which is going to be 27. And if we do all that math, 1/2 times 30 times 27, we'll get 405 square feet. Okay. All right. So let's work on one that's got a little bit more detail to it. We'll call this one number 2. And again, we're given similar figure, and we're told it is a rhombus. And I did a terrible job on that diagonal, but you get the idea, right? All right, so let's say that this is 3 centimeters, and we're told that this is 4 centimeters, okay? And that's basically all that we're told, okay? Well, we know that if this one is 3 centimeters, and this is in fact a rhombus, that this one also has to be 3 centimeters. The issue is I don't know what this diagonal here is, but I do know that I have right angles everywhere inside of here. So I want you to think about the fact that you've really got a little right triangle right here, okay? And in this right triangle, you know that one of my sides is 3, and you know that your hypotenuse then, this would be my hypotenuse, is 4. I just need to find this other leg. And you guessed it, we're going to have to do Pythagorean. So a squared plus b squared equals c squared. C is my hypotenuse, which is 4. We'll call this one a 3 squared plus b squared. It's going to be 9 plus b squared equals 16. Subtract 9 from both sides. I'm going to get b squared equals 7. So that means b has to equal square root of 7, okay? Because I have to take the square root of something that's squared to get that by itself, which means I also have to square root that side as well. So that means this side right here is the square root of 7. Well, if that side is the square root of 7, remember in a rhombus that these have to be the same. So that means this one is also the square root of 7. So now let's talk about our formula and what we have. A equals 1/2. D1, let's call this one D1, is 3 plus 3, which is 6. Now, what do I do with the square root of 7 plus the square root of 7? Let's just think about that for just a second. Square root of 7 plus the square root of 7. Well, remember, you always have a 1 in front of anything, right? Because 1 times anything is just itself. So really, I've got 1 square root of 7 plus 1 square root of 7. I want you to think about that as being just like a variable. And so really what we end up with for an answer is 2 radical 7, okay? I've got 2 of those radical 7s. Kind of makes sense. So that entire diagonal is 2 radical 7. And again, this is commutative, so I can multiply this times anything I want. So 1/2 of 6 is 3. So I would really have 3 times 2 radical 7. And again, that just gives me an answer. 3 times 2 is 6 radical 7 centimeters squared. Okay, a little bit more involved on that one, but you can kind of get the idea of what you need to do, which will help you once you get into some of these other problems. So now let's talk about a kite. Let's look at a couple examples of a kite. And again, same exact formula, we just have a little bit different figure that we're talking about. Boy, I am wild with the pencil today. All right, so we have our 2 diagonals here. And let's say that this one is 4 feet. And this one is 12 feet. And we're just told that this one is 9 feet. All right, so again, area equals 1/2, diagonal 1. We'll call this one diagonal 1 and this one diagonal 2. So diagonal 1, I just take 4 plus 12, which equals 16. But now what am I going to do here? Again, I could have put some notation here for you to know what to do. But again, we know that these are bisected, all right? The long diagonal bisects the short diagonal. So if this one is 9 feet, that means this one here also has to be 9 feet as well. So I just add those two together to make the entire diagonal, which is 18. And then again, just do the math. And area will equal 144 square feet, okay? So pretty simple. Area equals 1/2 D1 times D2. All right, so let's look at one more example. Again, we're given a kite, and we are told that this is 3 centimeters. We are told that this is 5 centimeters, and we are told that this is 7 centimeters. Okay, so there's quite a bit of unknown information here, but we could get to this pretty easily. First things first, remember the long diagonal bisects the short diagonal. So if this one is 3 centimeters, then that means this one here also has to be 3 centimeters. So now really we're only looking for this part right here. We need to know what this part is. We know it's not 7 because it's obviously not as long as that one. What do we know about a kite? Well, we know that with a kite and with a rhombus that we have 90-degree angles everywhere, okay? So what I want you to focus on once again is the fact that I have a right triangle right here in this blue area, okay? And I know that one of my sides is 3, and I know that the other side, which is the hypotenuse, is actually 5. So yet again, you guessed it, Pythagorean theorem, a squared plus b squared equals c squared. C is 5. 3 is a, let's say, plus b squared. 9 plus b squared equals 25. If I subtract 9 from both sides, I will get b squared equals 16. which I will take the square root of, and all of a sudden now I get b equals 4, okay? So that means right here, this length is 4 centimeters, which means now I have everything I need to do my formula. Area equals 1/2 d1 times d2. Area equals 1/2 diagonal 1, we'll say is the long diagonal. 4 plus 7 is 11. Diagonal 2 is 3 plus 3, which is 6. And again, I can take 1/2 of 6, which is 3, times 11, and I will get 33 square centimeters as my answer, okay? So hopefully this has been helpful to you. Again, just remember this formula right here. It's what you're going to need. Area equals 1/2 the first diagonal times the second diagonal, and that's all you really need in order to find the area of a rhombus or a kite. Be sure to let us know if you have any questions or concerns, and we'd be glad to help you with those. Thanks.